Then it really hit me. I'm on the moon. I'm on the moon, and the excitement, the wonder, the thrill, the adventure of it all.
For those who don't know, the people who went to the moon back then experienced unusual sensations that affected their physical bodies. They were also affected mentally and emotionally. In other words, what they went through was no joke. But the question is, what really happened? How did they get to the moon and how did they return? That's what we're going to find out. But before we start, don't forget to like this video. This means a lot to us. Thank you very much. And now let's begin. In fact, it's almost impossible to imagine now that there were people back then who willingly rode a machine that had a high chance of killing them. But that's exactly what the astronauts of the Apollo mission did. In the eyes of the world, it was a great achievement for humanity. But behind the cameras, flags, and applause, it was an extremely dangerous mission, where almost every second could have ended in tragedy. 12 people have walked on the moon. But what's even more surprising is that each one of them rode a spacecraft that even some engineers at the time weren't sure would really bring them back safely. They were exposed to intense radiation that science didn't really understand very well at that time. They landed in a place with no air, extremely hot during the day, extremely cold in the dark, and capable of killing a person in so many ways. And the scariest part? Just a small mistake, a broken wire, a tiny leak, or a wrong calculation, and they might never make it back to Earth. Honestly, many former astronauts have said that luck was also a reason why the Apollo missions were successful. Yes, NASA's engineers are excellent, but sometimes they felt like their whole project was just held together by aluminum foil, tape, and prayers. There were some astronauts who came back with permanent damage to their bodies. Some also developed problems with their eyes and hearts after many years. And there were some who never made it home. This is the story of one of the most dangerous missions in human history. And why? Even before a single Apollo crew reached outer space, 3 astronauts had already died. On January 27, 1967, Gus Grissom, Ed White, and Roger Chaffee were aboard the Apollo 1 command module. They were on top of the Saturn 1B rocket at Cape Kennedy. This wasn't an actual launch yet. It was just a practice test. And what's even more surprising, the rocket didn't even have fuel at that time. But inside the capsule, there was something that many people didn't notice back then. It was filled with pure oxygen. At first, that seemed normal for NASA. They had already used it in the Mercury and Gemini missions before, without any problems. But there was a big danger in a pure oxygen environment. When there's too much oxygen in a closed space, even ordinary materials become like fuel. Velcro, which is just supposed to be a simple fastener, suddenly becomes like gunpowder when it burns. Even aluminum can catch fire, and even simple fabric can catch fire just from the heat of a wire. And that's exactly what happened. There was a spark from a faulty electrical wire. That would have been a small thing in a normal situation. But because the cabin was full of oxygen, in just a few seconds, the fire spread throughout the entire capsule. Suddenly, the inside of the Apollo capsule turned into an inferno. The crew tried to open the hatch, but there was another big problem. The door opened inward, and as the fire got worse, the pressure inside the cabin also increased. Because of that, it was almost impossible to open the hatch from the inside. The 3 astronauts were trapped. According to the investigation, they may have still been alive for around 15 to 30 seconds, while the fire consumed the capsule. No one made it out. And what's even more painful is that Gus Grissom had been complaining about that hatch for a long time. Even back then, he was already saying it would be dangerous in case of an emergency. He also had another famous line he said while frustrated during testing earlier that day. According to Gus Grissom, how are we supposed to get to the moon if we can't even communicate properly when we're just 3 buildings apart? And he didn't know that was actually one of the last days of his life. The last thing they heard from the capsule were screams. The Apollo moon missions hadn't even started yet, but it had already killed someone. Because of that tragedy, NASA was forced to change almost the entire design of the Apollo spacecraft. They replaced the hatch. They made it open outward so it could be opened quickly in case of an emergency. They removed many easily flammable materials from inside the cabin, and they stopped using pure oxygen while still on the launch pad. They replaced it with a mixture of oxygen and nitrogen until they reached orbit. In other words, the death of the Apollo 1 crew was the reason why the following missions became safer. Gus Grissom, Ed White, and Roger Chaffee, they literally paid the price so future Apollo astronauts could live. Until now, their names are still engraved at Launch Complex 34, the place where the fire happened. And after the tragedy, that launch pad was never used again. Now, when it comes to the Saturn V rocket, until now, it is still one of the most powerful machines ever made for mankind. It stands almost 36 stories tall. It holds almost 6 million pounds of fuel. And its thrust is so powerful, it's like more than 80 Hoover dams running at the same time. But what documentaries don't often mention is that every Apollo astronaut was literally sitting on top of a gigantic chemical bomb. The first stage of the rocket was filled with kerosene and liquid oxygen. And if the mixing of these goes wrong, the whole rocket could explode like a small nuclear weapon. Despite this, according to some engineers at the time, if there was a major failure with the Saturn V rocket, the crew's chances of survival were almost zero. This means that if the rocket explodes, that's it. In most possible accidents, the astronauts didn't really have a true escape plan. Yes, they had what they called a launch escape tower. This is the small tower on top of the command module that can pull the capsule away if the rocket explodes during the initial part of the launch. In theory, it could save the crew, but in reality, it hasn't been tested in a real emergency with people inside yet. And after a few minutes from launch, they no longer have a backup plan. If something goes wrong in the middle of the ascent, they're on their own. In other words, the entire Apollo program back then was like a huge gamble with real human lives, and sometimes they really came very close to dying. Just like what happened on Apollo 12 while the rocket was ascending out of Earth's atmosphere, it was suddenly struck by lightning. Not just once, but twice. Within just a few seconds, the rocket's electrical systems went haywire. The guidance computer went offline. Some critical data in the cockpit was lost. And the mission nearly spun out of control. In mission control, the team panicked. Our engineer was there because they didn't immediately know what to do. But there was a young flight controller named John Aaron. He was only 24 years old at the time. And in the middle of the chaos, he remembered an old test anomaly from a year ago. He suddenly told the crew, switch SCE to AUX. The problem was almost no one really knew what that switch actually did. Even the commander of Apollo 12 wasn't sure either. But since they had no other choice, he pressed it anyway. And miraculously, the systems came back online. Suddenly, the mission became stable again. If John Aaron had been absent that day, Apollo 12 would probably have ended within the first 2 minutes of the launch. And that's just it. They weren't even at the most dangerous part yet. Because once you leave Earth's atmosphere, that's when the real danger begins. The Earth has an invisible shield. It's a magnetic field that blocks most of the harmful particles from space. Everyone on Earth is protected by that shield their whole lives. But the Apollo astronauts, they're the only people who have truly gone beyond that protection. When they passed beyond Earth's magnetosphere, they were directly exposed to something that almost no one fully understood at the time. And these are galactic cosmic rays, and this isn't just ordinary radiation. These cosmic rays are atomic particles traveling at nearly the speed of light. It is believed that some of these come from the explosions of dying stars in distant parts of the universe. And when these hit the human body, it's not just simple radiation exposure that happens. It's like a bullet passing through flesh, but the bullet is as small as an atom. It directly pierces through DNA, brain cells, heart muscle, even the optic nerves in the eyes. While the Apollo cruise was quietly traveling to the moon, they noticed something strange. Even when their eyes were closed, they could see flashes of light. Sometimes it looked like a streak, sometimes like a small burst of light. Some even said it was like fireworks inside their eyes. And the creepiest part is they weren't warned about it. Even NASA didn't know what it was back then. Eventually, they found out that those flashes were actually cosmic rays passing through. Those atomic particles were literally passing through their eyeballs, retinas, and inside their heads. Every flash they saw was a particle traveling almost at the speed of light as it pierced through their bodies. That means, while they were in space, it was like they were constantly being shot by invisible bullets that they couldn't see and couldn't stop. According to the Apollo 11 crew, they could see almost one flash every few minutes while they were awake. And because the mission lasted a week, that added up to hundreds of particles passing through their brains and bodies. What's even scarier is that the human body has no natural defense against this kind of radiation, because throughout the entire history of life on Earth, it was never really needed. All living creatures on this planet rely on the Earth's magnetic shield to always be there to protect them. Only the Apollo astronauts were the people who actually tried to see what would happen when you go outside the Earth's natural protection, and as they get closer to the moon, everything becomes even more dangerous. The lunar module, or more commonly known as the LEM, is the spacecraft used to descend from orbit to the surface of the moon. And surprisingly, it's one of the most fragile vehicles ever made by humans. Its body is thin and made of aluminum. In some parts, it's said to be almost as thin as several pieces of aluminum foil put together. According to some engineers, there are parts that can be punctured using just a pencil. That's how thin it is. The company that made this Grumman removed almost everything that could be reduced in the design to save on fuel. Every gram of weight is important. That's why everything that isn't absolutely necessary was removed. And one of the things that was removed was additional radiation shielding. So while the astronauts were in deep space, the lunar module had almost no real protection against deadly radiation. Even its windows weren't made to look good. They're triangular in shape because that's smaller and lighter. There were also no real seats while they were descending to the moon. The astronauts just stood during the descent because seats would add extra weight. And even more shocking, there was no toilet. Even its landing gear was intentionally designed to get damaged with every landing. It was made to collapse a bit to absorb the impact. That means with every landing on the moon, the vehicle would immediately have permanent damage. If that was done to a normal aircraft here on Earth, it probably wouldn't be allowed to fly again. But in the Apollo mission, that was normal. And while they were on the surface of the moon, there was another danger that could kill them instantly: solar flares. If there was a major solar eruption while they were on the lunar surface, the mission would be over immediately. No warning, no bunker, no shield. In less than 1 hour, the two astronauts inside the LEM could receive a deadly dose of radiation. And NASA knew that. That's why they monitored the sun every day during the Apollo missions. And honestly, they were just really lucky. During almost 3.5 years of Apollo missions, there was no major solar storm that hit while the crew was outside Earth's magnetic shield. Because if that had happened, it's likely that some astronauts would have died on the moon. There was a solar storm in August 1972. This happened 4 months after Apollo 16 returned and 4 months before Apollo 17 launched. And according to studies, if astronauts had been hit by that kind of solar storm while on the lunar surface, they would have had no chance of survival. It wasn't technology that saved them back then, but timing. And as Neil Armstrong and Buzz Aldrin were approaching the Sea of Tranquility on July 20th, 1969, suddenly the onboard computer started to have errors. Codes 1201 and 1202 appeared. In other words, the computer was overloaded. It was almost freezing because it was overloaded. In Houston, a 26-year-old engineer named Steve Bales had to make a quick decision. He had only about 15 seconds to choose whether to continue the landing or abort it. And under the intense pressure of that moment, he allowed them to continue. But the problem didn't end there. As the Eagle lunar module was descending, Neil Armstrong noticed that they were heading straight for a massive boulder field. The area was said to be as big as a football stadium, and the rocks were as large as cars. If they hit that spot, they would most likely crash immediately. So Armstrong took manual control. While he was searching for a safe landing spot, the fuel kept decreasing. And while the whole world was watching on television, their remaining time was slowly running out. When the Eagle finally landed on the moon, there was only about 17 seconds of fuel left. 17 seconds. Any more delay. And they would have had to abort the mission if they went past the safe fuel limit while still trying to find a landing area. They could have crashed and exploded on the surface of the moon. And while all of that was happening, the White House had a speech prepared for the possibility that they wouldn't be able to return. President Richard Nixon himself had already approved the emergency speech written by William Safar. Its title was, "In Event of Moon Disaster." The speech was meant for the situation where Armstrong and Aldrin would be left on the moon until they died. They would slowly run out of oxygen or food while the whole world listened. And even scarier, this actually almost happened. In another Apollo mission, there was a malfunction in the ascent engine, and what was happened. The ascent engine of the lunar module was malfunctioning. If the engine didn't work, they wouldn't be able to leave the moon. They would be permanently stranded there. And do you know how they fixed it? Just with a felt-tip pen. The astronaut literally inserted the marker pen into the broken circuit so the switch would make contact. And miraculously, the engine started. Because of that, they were able to return to Earth. That's how dangerous the Apollo missions were. Sometimes, it wasn't advanced technology that saved them, but improvisation, duct tape, and a lot of luck. Honestly, it's like the entire Apollo program survived because of the human ability to improvise during emergencies. Sometimes, it wasn't advanced computers that saved them, but quick thinking when disaster was just seconds away. And no mission shows this more than Apollo 13 supposedly. This was the third mission that would land humans on the moon. But instead, it became one of the most dangerous survival stories in the history of space exploration. While the spacecraft was almost 200,000 miles from Earth, one of the oxygen tanks suddenly exploded. In an instant, the command module was damaged, and the simple moon mission became a desperate fight for survival. 3 astronauts were trapped in space for 4 days, and even worse, they were forced to live in the lunar module, which was only designed for 2 people. That means it was extremely cramped. They lacked resources, and they were slowly running out of clean air. One of their biggest problems at that time was carbon dioxide. As the crew breathed, its level in the cabin increased, and if it got too high, they would slowly be poisoned while still alive. The lunar module had carbon dioxide scrubbers to clean the air, but there was one big problem. The filters from the command module didn't fit. The designs were different. It's like trying to fit a square object into a round hole, and if they couldn't fix that, they would all die. So what the NASA engineers in Houston did was come up with an improvised solution using only the things the crew had on board: a plastic bag, cardboard from the flight plan cover, and duct tape. While in space, the astronauts followed verbal instructions from Earth to make their own adapter. It was like a DIY project, but their lives depended on it. They called it the mailbox. And miraculously, it worked. The air in the cabin was clean again. But even though they were saved from that, it didn't mean they were safe yet. As time went on, the inside of the spacecraft got extremely cold. The temperature dropped to around 3 degrees Celsius. They were almost freezing inside. This was to save the remaining power. They also had to reduce their water intake. Because of that, the whole crew suffered severe dehydration. Fred Hayes even developed a kidney infection that lasted for several weeks after they returned to Earth. So, meanwhile, Jack Swigert, the command module pilot, was only included in the mission at the last minute because the original crew member was exposed to German measles. He manually computed navigation corrections. There was no advanced calculator. He only used a slide rule and a wristwatch, while most of the spacecraft's systems were almost shut down. And while the spacecraft was slowly drifting in space, they kept trying to find a way home. In the end, they made it back. But according to Tim Lovell, Fred Heiss, and Jack Swigert themselves, even now, they're still amazed that they survived that mission. Eventually, NASA called it Apollo 13 as a successful failure. But there's one thing that people often forget about that phrase. Almost all the systems of the Apollo missions were the same. Same oxygen tanks, same design, same technology. That means any Apollo mission. Any mission could have become Apollo 13. The question wasn't if, but really just when it would happen. And even after they managed to get through all of that, they still had one last challenge: returning to Earth. Because coming back from the moon. It's also one of the most dangerous parts of the whole mission. When the Apollo capsule re-enters the atmosphere, it reaches over 24,500 miles per hour. Because of its incredible speed, the air around the capsule practically catches fire. The air in front of the spacecraft is compressed so much that it turns into plasma. Superheated gas reaches around 2,700 degrees Celsius. That's hot enough to melt steel, their only protection. A heat shield that gradually burns up as they return to Earth. It's designed to burn layer by layer to keep the heat away from the capsule. But there's a catch. If their angle of entry into the atmosphere is even slightly wrong, they're dead. If the angle is too steep, the capsule will burn up. But if it's too shallow, they'll bounce off the atmosphere, like a stone skipping on water. And if that happens, they'll drift back into space until they run out of oxygen. The correct entry path is extremely narrow. According to some engineers, it's like trying to get a thread through a basketball hoop from 100 miles away in the dark while you're on fire. And while they're in the hottest part of re-entry, something else terrifying happens to the capsule. All communication is lost because of the plasma around the spacecraft. All radio signals are blocked for several minutes. Mission Control has no idea if the crew is still alive or if the spacecraft has completely disintegrated. And inside the capsule, the astronauts can see what's happening. The blazing orange and pink plasma outside the window makes it feel like they're inside a giant furnace. And in those moments, there's nothing they can do. They can't ask for help. They can't change direction. All they can do is hope that the calculations are correct and that they won't burn up on their way back to Earth. In those moments, as they're returning to Earth, there's nothing else they can do. All they can do is wait to see if the heat shield can withstand the extreme heat, wait to see if they'll wake up after the radio blackout, and wait to see if they'll make it home alive. But even for the astronauts who made it back, it doesn't mean there was no price to pay for going to the moon, because there are effects that aren't immediately visible. In 2016, a study was conducted by Dr. Michael Delp from Florida State University. They examined the causes of death among Apollo astronauts who went to deep space and compared them to astronauts who only went to low Earth orbit and to astronauts who never flew at all. And there was a surprising result. The Apollo astronauts, the only people who truly left Earth's magnetic protection, died from cardiovascular disease at more than 4 times the rate of other astronauts. And what's even more unusual is that the same effect wasn't seen in astronauts who only orbited the Earth. According to the study, it's possible that deep space radiation slowly damaged the cells of their blood vessels. Not suddenly, but gradually, over time. And it may have taken decades before the effects finally appeared. Alan Shepard, the first American in space and the 5th person to walk on the moon, died of leukemia. When it came to Jim Irwin of Apollo 15, he experienced heart arrhythmia while still on the moon. And a year after returning to Earth, he had his first heart attack in 1991. He died from a final heart attack at the age of 61. Ed Mitchell. Ed Mitchell of Apollo 14 passed away in 2016, and Neil Armstrong. He died due to complications from heart surgery in 2012. Until now, scientists are still debating if these are really consistent effects of radiation in deep space. It's hard to give a final conclusion because the sample size is very small. Only 24 people in all of history, the ones who actually went beyond low Earth orbit, and only 12 have walked on the moon. The number is too small to come up with a definite answer. But one thing is certain: those 12 moonwalkers. They experienced more intense deep space radiation than anyone before or after them, and whatever effects it had. Science learned from their bodies, but it wasn't just their bodies that were affected by the Apollo missions. Their minds were too, and sometimes that's even harder to measure. When Buzz Aldrin returned to Earth, he fell into deep depression and alcoholism. Later, he wrote that coming back from the moon was harder than actually going there, because after he saw the Earth from space, many things here on Earth seemed small and insignificant. Charles Duke also experienced the same feeling for many years. Edgar Mitchell, on the other hand, had an intense spiritual and psychological experience while on his way home from the moon. According to him, he felt the connection of the entire universe. He spent the rest of his life trying to understand that experience. Eventually, he left NASA, and he established an institute to study consciousness and the human mind. In a way, those who walked on another world came back to Earth as if a part of them was left there. It's like they never fully returned to their old lives, because the truth is, they went to a place that wasn't really made for humans. Even now, Apollo is remembered as a great achievement, and that's true. But often, that's the only version most people hear, is the clean story. The flags on the moon, the footprints, the golf balls hit by Alan Shepard. That's the version taught in school. But the real story. 24 people literally rode on fire into a vacuum that almost no one understood back then. They went to a rock that no human had ever visited before, using a spacecraft made almost entirely of thin aluminum and improvised engineering, while radiation was still penetrating their eyes and bodies. The real story: there were astronauts who saw their friends burn alive before the program even started. And that's the real story. The reason why 12 moonwalkers were able to return from the moon is simply because nothing went wrong at the wrong time. There was no solar flare that hit on the wrong day. There was no critical switch that stayed broken for a few more minutes. There was no fire that started while they were in deep space. In other words, we just got lucky. 12 people were able to walk on the moon, and miraculously, they all made it back. And the next time humans try to go far from Earth again, we can't just rely on luck anymore. A thin lunar module is no longer enough. Improvised fixes using a pin and duct tape are no longer enough. The next generation of spacecraft will be designed more carefully, because now we know things that the Apollo missions didn't know back then. The moon is not just a simple destination, it's a place that may let you visit. And if it wants to, it might not let you go home. It can.